Okay, everyone, can you hear me? Okay, children. So last day we discussed about how we can design a database using ER diagrams. Today we're gonna go a step ahead to the logical level. So today we're gonna discuss how we can develop tables using the ER diagrams and by creating relationship with each entity. So there are some rules that you have to follow or some practices you have to follow when you're going to develop tables depending on the ER diagram. Right, we'll see one by one. Okay, children, so this is how we're going to develop the table. So you can see table entity name is there. Then attributes are listed down the topic. Again, there are connections, right? Those are connected together. And this is how we are going to develop the logical level. Okay. Children, we'll shall go with an example. I think you all remember this case. So this is related to the library. Last day we discussed about this case and we designed the database for the library. So then you don't have to draw the ER diagram again because you already have that with you. So we'll develop the table, I mean the logical tables depending on this ER diagram. Children, this is a common one. I mean there can be some uh, mismatch with your ER table and this one. So you don't worry about that. You can go with your own design, right? It's okay. Right, children, so this is the ER diagram we drew earlier. So book, title, and ISBN, student name, registration number, and author. That all the relationships are listed here. Again, children, I haven't mentioned the partial and total relationships in this ER diagram. That is because this is just for your reference, right? So then you can go with your own own ER diagrams. So I haven't mentioned the total and partial participation in this ER diagram. Okay, this is just a reference for developing logical diagrams, logical tables. Okay. So let's see how we can do that. So children, here we have one-to-many relationship and many-to-many relationship, and again one-to-one relationship also there. So then depending on the relationship type also, the way that we are going to create the table is being different. Right? We'll learn by one by one. So okay, children, if you have any issues, please ask me because this can be a new thing to you. So then there can be some problems, issues. Please ask, right? Okay, I think you all have remember the ER diagram. I think so. Take your ER diagram as well. Okay, take a paper. Then we are going to design the tables. Right? Okay, first relationship that we're going to consider is book and the location. So that is a one-to-one relationship. That is a one-to-one relationship. You can see in the diagram, book and the location. So children, these are some data I have entered in the table. So this is for your reference again. These are just examples. So we don't have to have data to create tables, right? We are not include data in the logical diagram. So this is for just only for your understanding, right? So you don't have to draw tables in this way because this is not the way we're going to follow to develop tables in logical diagram. So this is just this data is given only for your understanding. So children, you can see by just referring to the data, computer basics, location ID 1. So rack number 5. Programming, location ID 3, rack number 6. So like that, every record in this table has a relevant record in the location table. So in our ER diagram we draw this as a partial participation so that there can be more records available in the location table. That's okay, right? I'm just using only 3 records here. Okay, children, now we are going to connect these two tables. So this is the way, children, we are going to uh, write these two tables. You can see book, that is the entity, then ISBN, comma, title. After that, location ID, fact number. And to make the relationship, what we have done is we have inserted this location ID into book table. See, the location ID is here. So now the location ID is the foreign key of this table. That is the foreign key. And ISBN and location ID are the primary keys. So children, now we can understand in a one-to-one relationship, to make the relationship in the logical level, what we do, we insert one primary key, primary key of one table into another table, and we create the relationship. It's really simple. So you can add ISBN number into location table, or you can add location ID into book table. Both ways are correct. Even you add the ISBN into location or location ID into the book table, both ways are correct, right? So then if it is a one-to-one relationship, that is really easy. Is that clear? Okay, then now the issue comes. So when we have a one-to-many relationship, there is an issue. Yeah, there is a request to explain that again. So I'll explain it again. If I go back here in the ER diagram, so in the ER diagram, we have one-to-one relationship about book and the location. So in the book, we have title and ISBN. The location, we have rack number and the location ID. So in this table, ISBN is the primary key. So this is the primary key. And in this table, location ID is the primary key. Now to make the relationship between these two tables, what we can do is we can insert one primary key into the other table. So to make the relationship, location ID is inserted into book table. So now here, this is the primary key of the location table, and ISBN is the primary key of book table, and the location ID, when it is inserted into the book table, now that becomes the foreign key of this table. Location ID. Or we can do the other way as well. We can insert ISBN into location table also. So then here the ISBN will be the foreign key. So we don't have to insert location ID always into the book table. So we can do the other way as well, because this is a one-to-one relationship. So in a one-to-one relationship, to prepare the logical diagrams or the logical tables, what we do, we insert one primary key into the other table and make the relationship. Is that okay now? Then it is better if you can ask the questions, right? So even in chat, yeah, that's also good. Again, if you can ask the question, that also will be better. So this lecture series will feel like alive. Otherwise, I'm just talking to the laptop, and I don't know what you are doing the other side. So then always try to reply in chat or even to talk. Okay, right. Next one, one-to-many relationship. So in one-to-many relationship, the things are different. So children here, so you know now what we have to do to make a relationship is insert one primary key into the other table. So if we take the relationship between book and the author, you can see that is a one-to-many relationship. Okay, so many side is in the book. That means one author has many books, and for one book there is only one author. Okay. So children, M or many is at the book side, right? So then what you're gonna do now, to make the relationship, we need to insert one primary key into the other table. So in this example, what we have done is we have insert ISBN into the author table. So I have taken the primary key from many side. So this table has many, right? The meaning of that is for one record of author table, there are many records in the book table. That's the meaning. So children, when I insert ISBN or the primary key of the book table into the author, you can see there is no way to add other books belong to these authors. Is that clear? So now these three are already filled because in this author table we have only three authors. There can be more books here. Here I have mentioned only three, but there can be more books. So then when we're going to insert multiple books into one author, there is no room here to add that ISBN. For example, assume that I have another book. The number is 1, 2. Let's say 1, 2, 3. And that is the book name is ABC. So now I have a book. Now the book is written by some, let's say, first author Saman Kumar. Then again, what I have to do? I have to repeat the same thing again. 001 and the name here and book number 1, 2, 3. See what has happened now, children. The same data here, here, and here. The same name is repeating multiple times. Even that author has more data about his phone number, address, and those data also they are in the table. Then those data also have to be repeated. Every data related to that author has to be repeated to enter data for this foreign key. මේ table එකට අපි data දාන්න ගියොත් එහෙම many තියෙන පැත්තෙන් අපි primary key ගෙනල්ලා one පැත්තට ගෙනවොත් වෙන්නේ the data going to be repeated in the table because there is no room to add multiple data for one record in the author table here. So then we can't do that, right? In a summary, when we have a one-to-many relationship, we can't take the primary key from many side to the one side. We can't do this one. This is not possible. Is that clear? If you want me to further explain, please ask. Okay, then we'll see the other way, right? Here. Here, what we have done is we have inserted the author ID into the book table. Okay, children, give me 1 minute. Okay, children. So now, so here what we have to do, we are going to insert primary key from the author table into the book table, because we have one side in the author table, right? So you can see one is related to the author table and many is for the book table. Right. So then what we have to do here is we have to take the primary key from the one side table and insert that into the many side table. Then you can see here. So look, author, sorry, yeah, here. Author ID is now inserted into the book table. author ID is inserted into the book table. So then there's a one-to-many relationship. That is how we can link these two tables. Right. Is it clear, everyone? When it is one-to-many relationship, how you can do it? So always you have to take the primary key from the one side table and insert that into the book side table. So this primary key become the foreign key here in the book table. Okay, we'll see next. Our next relationship is many-to-many one, book student relationship. Yeah, that is here, many-to-many. So now we already know when there's many relationship type is there for a table, we can't get the primary key from that side or from that table. That is why in one-to-many, we did the same. Right? We get primary key from the one side. Right. So then what we have to do, we have to create a new table for that relationship. Here you can see a new table has been created as lending. So from book table, we can't get the primary key. From student table, we can't get the primary key and insert that in the other table. So what we going to do in many-to-many relationship is we are going to take both primary keys from the tables and we are going to create a new table and insert primary keys. Now this is how they're going to link. So this is connected to here and this one is connected to here. Right. So in this one you can see the book table and another table is here called lending. And both the primary keys are inserted into that table as foreign keys. Okay. Everyone, is that clear? How you can combine tables or connect tables using primary keys and foreign keys? Right, children. So this is now return date and the lend date. So those two are related to this relationship. We learned about these attributes which are belong to relationships. So here return date and the lending date. පොත දුන්නු දවස සහ බාර ගන්න ආපහු දෙන්න ඕනි දවස. So these days are related to the relationship. That means when some student going to take a book, only a value will be added to these attributes. So children, we can add that into the lending table then. So this table is totally created for the relationship. So lending date and return date will be there in the table which is created for the relationship. Right. So this is the ultimate design of the logical level for our database, which is going to be created for the library. Okay, everyone. We shall move to the next one. Before that, children, we must know about the data types related to those attributes as well, because this is also one uh, feature of developing databases, design databases in this logical level. So every time that we're going to introduce an attribute, we must mention what is the data type of that attribute as well. So these are the data types, common data types available in database management. There are more, but we are just discussing only the common data types. So if you are using numbers, that comes as integer, or int is the keyword for integer. So these are whole numbers, like integer. Then children, we have characters like letters, symbols, those things. So for characters, we use the keyword as char, characters, char. Then children, another character type is there, that is called variable character. So variable character is normally what happens, in a variable character, we can add multiple letters like words, sentences. So if it is sentence is there, that comes as a variable character, or we call it, the keyword is vacha. Clear? So in char data type, the character data type, there is only one letter or one symbol, char. If we have multiple letters or multiple words in our input or the record, I mean the data, so we have to use variable character or vacha. Actually, another data type is they are called string. Children, there's a difference between this string data type and the varchar data type. Both are same. Both variables, or sorry, data types are used to store characters, multiple characters or words, sentences. But the thing is, if you define one data type as string, then the number of characters, or yes, number of characters will be a fixed value. That should be a fixed value. So here you can see there are 9 spaces are there. Only 7 have been used. Okay. Then even there are no characters in this space, the string data type creates the entire space. But if you use varchar for the string, I mean, to keep the letters or sentences, then that will create the space only for the relevant letters. That is the difference. We'll study that further. Then children, if there are some decimal points, floating point numbers, then we can use float as the reference, I mean, as a keyword. So date and time, the date and time are the keywords. Okay. So like that, when we're going to define the table or logical diagram, we must give the relevant data type as well. Okay, so there's a question. The lending entity in the last slide, should we underline all four attributes? Like a good question. So here in this one, actually we don't need to underline all four characters, but here in this table we don't have a primary key. So in that case, we have to combine several attributes and make the primary key. So if we combine registration number and the ISBN, that also cannot be used as a primary key because the same student can take the same book again. So then there will be multiple values. So a primary key cannot have multiple values. So then we have to use the lending date or return date uh, as the composite key that we can use as the primary key. So it's a composite key. That means combination of multiple attributes. So that is why all these four have been underlined. But even if you just take three, that is also enough. Okay. Ask a question, Sharon. That is good, right? Right, children. So now this is the final diagram. So this is how we are going to design the logical level of our database. Here you can see this is the book table, ISBN, ISBN, and INT. That means it's a number which has 12 digits. So we have allocated 12 digits for that one. Title, Vacha, 200 letters. Location ID is string 6, auth ID 3. So children, then that is connected with the lending table. And again, student is connected through the lending table. So you can see here, the data type is INT and 6 digits for the registration number. Here also the same. So we should keep the consistency of these elements. Again, here ISBN, INT 12, then here also INT 12. So like that, you have to maintain the consistency of data type as well when you're going to add those as primary keys and foreign keys. Then again, you can see the book table is connected to the location table. And again, the book table is connected to the author table. So now here, what you can see is earlier there was a many-to-many relationship between these two tables. I mean, these two entities. This was many-to-many. But with the intermediate table here, that was divided into two many-to-one, one-to-many relationships. Clear? Okay. Earlier we had only four entities in the table, but in the design. But when you're going to create tables, when you're going to move into the logical level, now there we have 5 tables here. Right, children, everyone, is that clear for you? How you can develop the logical diagram? Because now we are going to practice some other examples. Before that, I want to make sure that you have clearly understand how you can convert your design into a logical database design. So how to put primary key and foreign key and how to make relationships. Everyone, please reply in chat or you can comment. So is it clear for you? Others? All right, we shall go with another example. Right. So, okay, children. So this is a notification. This you can see one, many, one and only one, zero and one, I mean like that. There are some notifications which we can use in this logical diagrams. So here, this indicates many, sorry, one and only one. Here there can be one or many. So like that, we can give some notifications. So here, there can be some locations. Again, there can be some zero allocated locations as well. I mean, there are locations no without books. So that can be indicated in this way, 0 or 1. So this is how we're going to mention that partial and total participation in relationships. Here you can see, for example, here, book and the location table. Book and the location table. So this says one and only one. So one and only one book. We know that there is only one location. But there can be more locations. There can be locations which doesn't have books. So that indicates by this 0. That means in locations for one book, there is a location, but there are locations which doesn't have books. So in this relationship, one author, one or many books. Here, one or many. For one author, one or many books. Right. So like that, using these notifications, we can indicate the relationship or the depth of the relationship. We shall try another example. So this is about the company. This is also a family example because we have already read the case, and again we have already designed the ER diagram. I mean, we have already designed the database. So we are going to move with the tables now. Right. So now this is the ER diagram. Now, children, let's see how we can develop the database. Okay. Now, this is the initial step we all try together. Let's start from 1. Right. So there are altogether 4 attributes. I'm going to start from department, employee, like that. And you can start from any, right? but it is, you can go with the order. So I'm going to type department. So this is actually how we are going to design the database. I mean, design the logical level, right? Okay. So first of all, we have to mention the entities and then the other connected attributes for that entity only, right? So we'll see. You also can write with me. First, we have department. Within brackets, first we are going to mention the key attribute, department ID, comma, common name, and we have department head. Then department head. So make sure that you are writing the attribute as one word here, right? So see, I'm separating the words by cases. So first letter capital. I'm not giving any space in between words. Okay? And number of employees, right? Okay, come on. So these are the attributes of the department table. Then we check about the employee table. Okay. So let's continue then. Have date of birth. Okay. So then after that, the next entity we have is project. In project, we have project ID. Workstation ID and the category. Right, children. So now we have developed the basic tables. Now everyone clearly understand how we can create relationship between these tables in the logical level. So what we have done already is we have created the basic tables only, right? Now check the relationship. So now very careful listen everyone. So if we take first one, let's take employee and workstation. So one-to-one relationship is there. So then employee and workstation. So we can take primary key of employee and insert that into the workstation table. Or similarly, we can take workstation ID from the workstation table and update that or insert that into employee table. Both ways are possible because between employee and workstation, there is a one-to-one relationship. So then it will be easy for us to have the employee ID from this. And I'm going to add employee ID into the workstation table. Now then that relationship is okay. Clear? So this is the foreign key of the workstation table now. Okay. I'm going to close the bracket. Right. Next one, project. Then yeah. Then about department and employee. So department table is here. Employee table is here. So the relationship is one-to-many relationship. The relationship is a one-to-many relationship. One-to-many relationship. So children, now we have to take the primary key from the table which has one. We can't take the primary key from the table which has many. So we have to take primary key from one side. Then we have to insert department ID into employee table. We cannot add employee ID into department table. Right? So in a one-to-many relationship, we have to always take the primary key from one side table. Then we have to insert department ID into the employee table as the primary key. Then about the project and the employee, we have a many-to-many relationship. So then we can't get any primary key from any side and insert that into the other side. So if it is a many-to-many relationship, keep in your mind, always we have to create a new table for that, for the relationship. Then employee project, we can give it a meaningful name. So I'm going to give, we can say employee project table or employee assignment table, any name, right? So then in that table, we are going to insert employee ID and the project ID. Right. Now this is the initial development of the table. I mean the logical level table. Everyone just correct your ones and please reply when you are ready. Then we can go to the next step, right? Right. Everyone, please try to understand. And then when you are ready, please reply. Okay. So project also, we have to close the bracket. Yes. Okay, everyone. Children, there are 53 students joining, so please, I need your reply. Okay. Otherwise, we are going to waste the time until if you are not replying. Okay. So if you are not replying, I'm going to continue. So then here, this is what we're going to do next. We are going to develop the design again. So we are going to develop one by one. So we have department, right? Department table. There we have department ID and department name, head, and number of employees. So these are the attributes. So this is the title of the table. I mean, title of the table or the entity. Now, children, we have to mention what are the data types. So department ID. So that depends on the database designer. So how you gonna define the database ID? For example, assume that as a database department ID, you are going to take D1, D2, D3, D4 like that, or you can take 1, 2, 3, 4 only. So then the data type will be different. So assume that you have taken a department ID as 1, 2, 3, 4. Then you have to mention INT and one digit. So you have to mention INT 1. Because you are using 1, 2, 3, 4. That means only one digit is there. Again, assume that you are going to take a D1, D2, D3 like that. So then we have to go with string or varchar. So we know that exactly there are two letters are there, then we can go for string. String 2. Right. Now here department name. So department name, there are, I mean, the length of the name is different. So exactly we know that there are characters there, that means letters and words are there. So we can go for string data type or varchar data type. But string, we are going for fixed value data. I mean, the number of characters are fixed. But here we don't know how many characters or letters will be there in the name. So then we can go for varchar. So let's say 50 characters. You can enter 60, 65. That is okay. But children, this number actually, what this number says is the memory location, memory allocation for the relevant data type. So here, when I put 50 here, the meaning of that is I have allocated 50 spaces in the memory. It doesn't matter. You can say 500 or 5,000. But what you are doing then? You are wasting the memory. So wasting the memory, and when your program is going to occupy high level of memory, then your program or the database will slow down. That will not efficient. So then that is why we reduce the memory size to the only to the relevant or only to the necessary amount of capacity. So then for a department name, we can assume that there will be only 40 characters, but you don't have to assume actually. So what you can do is just write down the longest department name and count the characters there. Then you can set the value to the longest department name number of characters. But for just for teaching purpose, I just said 50, but that is not the way we are going to add the number of characters. Clear? So we have to get the highest length statement, and you have to count the characters in that statement, and the highest value or the number of memory locations that we're going to allocate for that variable is depend on that value. Clear? Right. Then department head, same. It's a name, so we can go for varchar. Number of employee, that should be a int, and let's say 2 digits. Children, two digit means we can mention a value up to 99. Right. Then this is okay. Next table, employee. We have employee ID. In a paper, you can practice with me, okay? Right. In children, we have to decide the data types. Employee ID, again, it's up to you to decide how many characters are there in the employee ID. But normally, let's say it's an integer, or you can go with the string as well, right? I'm going to say it's a 3-letter integer. It's a number. Employee name. For a name, we can normally go for, actually, we have to go for varchar, and we can give 50 characters there. Right. NIC, again, we can go for varchar, and we exactly know that the maximum number will be 13. Address, we may have to go for 100. Then mobile number, we can go for string because we already know there are only 10 characters or numbers there. Then date of birth is the date. Age, again an integer, and int. And there will be only 2 digits, right? So normally we can count up to 99 in 2 digits. Yeah. We can't use char. That's a question. Can we use char for NIC? No, char is just one letter, right? So for characters, there are 3 data types. Char is for one letter. Variable char or varchar is for multiple letters and words, sentences. And string is also for sentences, but strings we use only for the fixed value statements. Right? Then, so NIC, we can't use string because there are some what we call some numbers have 9 digits, some have 13. So we have to go for varchar in NIC. Char is only one character, right? Okay, so always please ask questions. Then department ID. So we have to exactly go for this data type here in the department ID as well. We have to maintain the continuity. Right, then project. Right, there are only 3 attributes. So project ID, again, you can define a value for that one. Let's say it has a letter and 2 digits. So then we can go for 3. For example, P11, P12, like that's the data will be like that. So those are assumptions, right? So when you're going to design the database, you have to go with those assumptions because that value or the data type depend on the data that we're going to store in the table. Right? Project name also, again, we can go for 50. Supervisor is also a name, then we can go for 50. Right. We have another table that is workstation. It has workstation ID. Category. Children, you also can write with me, right? So then only you will understand. Employee ID. Right. So workstation ID again, same. You can decide the data type. Category, also same. Now employee ID, so we already have employee ID defined. So then you have to use the same data type there. Now we have another table, so we have to create that table as well. Employee ID. And project ID. So children, for these two, again, you have to use the exact data type that you have used in the original table. So employee ID, we have used int3. For the project ID, we have used here string. Right. Okay, so this is the design. So now we have already completed the logical design of our database. So if I just show you how these are connected, then here department ID, sorry, department is connected to the employee table with the department ID. And workstation is also connected through the employee ID. Yeah. And project is connected through the employee project table. Okay. Then children, we must underline the primary keys. So here, this is the primary key. And employee ID is the primary key of this table. Project ID. And here, workstation ID. And in this one, children, you have to underline both. Because you have to take both as the primary key. It's a composite key. Now, what are the foreign keys then? Here, this is a foreign key. And this is a foreign key. See? And here, these two are foreign keys. That is how the table design is going to be finished by just connecting the table via using primary keys and foreign keys. Right, everyone? Is that clear? Okay, now let's move to the next one. Next case, that is also a familiar one. We already designed the database, designed the database using ER diagrams for the airplane, the airport case as well. So I'll show you the ER diagram. So it's a simple one. Please try to develop the try to develop the logical design with the data types by yourself. I'll give you some time.